Hey everyone, welcome to This Explainer. Today we're jumping right into Chapter 9 of our source material to really decode the foundational mathematics of fractions. We're going to completely strip away the confusing jumble of numbers and translate them into a highly visual, intuitive language, demystifying the journey of the whole. To keep things simple, we're breaking this down into 5 quick steps. 1. The concept of fractions. 2. Numerators and denominators. 3. Understanding unit fractions. 4. Equivalent fractions explained. And 5. Adding and subtracting fractions. All right, Part 1. The concept of fractions and sharing things equally. Let's start with a real-world problem we literally all face, sharing food. Whether it's splitting a guava right down the middle with your sibling or carefully cutting up a cake so all your friends get a fair piece, fractions are simply the mathematical solution for breaking a whole unit into equal parts. It's basically just ensuring fairness through math. So the very first distinction we need to nail down is the difference between whole numbers and what the material calls proper fractions. Unlike a whole number, like 1, 2, or 3, a proper fraction represents a value that is strictly greater than 0, but distinctly less than one whole unit. You might not get the entire cake, but hey, you're definitely getting more than nothing. And we can easily ground these abstract concepts into real, recognizable shapes. Look at the hexagon. If we shade 2 of its 6 equal parts, we get 2/6. Or if we color in 5 sections of a 9-part grid, that's 5/9. The logic holds up perfectly every single time. The entire shape is our 1, and the colored sections are the fraction we're looking at. Moving right along to Section 2, numerators and denominators, naming the pieces. First up, we have the denominator. You can really think of the denominator as the absolute foundation of your fraction. It's always written on the bottom, below the line, and it tells us exactly how many total equal slices make up our entire cake, or hexagon, or whatever whole unit we're dealing with. It completely anchors the whole calculation. On the flip side, we have the numerator. This is the number sitting proudly on top of the fraction line. The numerator simply tells us how many of those equal slices we're actually looking at, sharing, or, in the case of our cake, eating. Watch how seamlessly these terms map together when we look at the fraction 4/7. The numerator, 4, sits up top to represent the parts we actually have. Meanwhile, the denominator, 7, holds down the bottom to show the total parts the whole was originally divided into. It's just a super neat, compact way to convey a lot of visual information at a glance. Next up is Section 3, Understanding Unit Fractions, the Building Blocks. Okay, so a unit fraction is essentially a single slice of our mathematical pie. By definition, it's a proper fraction where the numerator is always exactly 1. Why does this matter? Well, because once you have a unit fraction, it's like a Lego brick. You can stack these single slices to create absolutely any other proper fraction you could ever need. Here's that building block approach in action. If you take one unit fraction of 1/3, and you combine it with a second unit fraction of 1/3, boom, they naturally add up to exactly 2/3 of the total circle. It is completely intuitive, highly visual math. Which brings us to Section 4, Equivalent Fractions Explained. Same value, new numbers. This is a fascinating conceptual hurdle that often trips people up. I want you to consider this. Can different fractions, using completely different numbers, represent the exact same physical amount? Think about it. If I cut a circular card into 4 pieces and take 2, do I have the exact same amount of card as if I cut it directly in half and took just 1 piece? The answer is a resounding yes. Through a simple practical exercise of folding circular cards, we can visually prove that 1/2 takes up the exact same physical space as 2/4. Different cuts, identical mathematical value. That is the magic of equivalent fractions. Finally, we arrive at Section 5. Adding and subtracting fractions, operations on fractions. Now, to make sure you never make a mistake here, Chapter 9 gives us a crystal clear method. Step 1, ensure your denominators are identical. Step 2, do your math, add or subtract, but strictly on the numerators. And Step 3, keep that denominator exactly the same. The absolute key takeaway here is that our total number of equal slices must remain completely unchanged while we add or subtract. Let's put that into practice with an example straight from the text. When subtracting 2/7 from 5/7, we strictly subtract those top numbers, 5 minus 2, to get 3. Meanwhile, our denominator of 7 predictably, safely stays exactly the same. That gives us our final answer of 3/7. It perfectly follows the rules we just laid out. We've come a long way from sharing a simple guava to confidently subtracting numerators. But I want to leave you with a provocative thought to chew on. Knowing that fractions are really just equal parts of a whole, where else in your daily life are you already calculating fractions without even realizing it? Think about it. How many everyday tasks, like managing your schedule, splitting a dinner bill, or measuring out ingredients for dinner, are secretly just fractions waiting for you to solve them? Keep your eyes peeled because math is quite literally everywhere. Thanks so much for joining me for this explainer, and keep exploring.